Okay, tell me when. Amazing. Now we are also live with the virtual Java user group. So hello to everyone online joining us. We have some humans in the room as well from the LJC. But tonight we're going to have 3 amazing speakers in this particular order. And so I don't want to talk for too much longer, but just anyone in the room, we will have some more drinks and some pizza after the event. And for anyone watching, please throw your questions in the YouTube chat. We'll ask questions live from people in the room, but also from our vJUG audience. So any vJuggers who have any questions during the session, just let me know. But without further ado, I'm going to invite up our first speaker, Andres, and he's going to be talking about agentic memory, ripples of the matrix. Dun, dun, dun. Dun, dun, dun. Do you want to hold?
Thank you so much. Maybe there, yeah. I don't know. Wait a bit.
Perfect. Over to you.
So this is for the room. Can the room hear me? Right? This is on the other side. Is the other side live too? We're good all around? Good. AV checks are over. We can actually get into it. You know what?
Thank you.
It's been like 3 years since I've talked to Java people. It's so good to see you. And I have a trivia question for you. Neo4j. Who can think why there's a 4j at the end of that word? Anyone? For Java, but why? Who's been in the Java community long enough to remember the 4Js? Somebody help me out, really? Have none of you used SourceForge? Okay, so then here's your trivia for the day. Back before GitHub existed, there was SourceForge. And on SourceForge, when you had a Java project, one of the things people would do is use 4J at the end, which you're supposed to cheekily sort of say Forge, because it's Java, haha, 4J, for Java, and it's on SourceForge. So now you know your trivia for Neo4j. It is the matrix combined with a Java reference. Okay, that's my talk. Hope you guys have a good night. I am ABK of Neo4j. I've been building multi-agent systems for the last, I don't know, I'm going to say actually only 9 months to be fair. And within that, there's lots of interesting things about multi-agent systems, but most particularly because, of course, I'm a database person, I've been very, very interested in how to start thinking about and structuring memory. For a lot of people who get into doing stuff with agentic memory, they go down kind of a cognitive sciences path. I do not do that. I think that's very valuable. It's a very useful way to think about how do we remember things? Is it reconstructed memory? Is it fetching things? Anchoring memory in different ways. I don't care about any, I do care about that, but I don't focus on that. For me, I think a lot about just what is my sort of software engineering perspective on like how do you deal with memory within the context of building agents and what are the structures required for that. So that's what I want to share today. And I should say that this is an exploration of the problem space rather than recommendations about how to solve it. Come to my next talk in maybe another few months for the solutions. Okay. Famously, William Gibson had said that time moves in one direction and agentic memory in another. From the Neuromancer. You all remember that quote, right? He knew about agentic memory. But think about that. So time is, of course, a very useful dimension for thinking about memory. And so this is a very classic, hopefully that shows up well enough, not high contrast. If you've got time going up and down, you've got this plane for space. Of course, space really forms a hypersurface because it's not just flat, it's, you know, it's space, so it's all kinds of dimensions. And we have an observer within space at a moment in time. What does that moment in time really mean? And how does that affect the universe? How does the universe affect that moment in time? There's this idea of a light cone, which projects backwards in time, and it's the past, right? The light cone is the representation of, like, for any point in space, traveling at the speed of light at a given time, what is within that cone that would be able to reach this moment in time where the observer is to affect the observer, right? There's another cone going the other direction into the future, which is, of course, the future light cone. Same idea. From that moment in time, in that place in space, that event that happens when that observer is observing and taking some actions in the universe ripples out, limited by the speed of light, through the universe and forming a cone going out forward in time. Does this all make sense? This is pseudoscience, but like science, right? Now I'm going to turn to the actual pseudoscience. What has this got to do with agentic memory? Again, this is a way of just framing things for me as I think about the behaviors of an agent working through what it's trying to get done. And just replacing some of the words so that the space isn't just outer space, the space around us, reality space, but the information space that an agent really lives in because of an LLM. And what an LLM is really doing is working through some kind of like really crazy information manifold that it has inside of its vector space, right? And everything within agent work is by guiding that particular moment in time where the agent is, the agentic context, for how it can travel within that information space across this manifold in whatever paths. So that means that the past, of course, is the memory of that agent, how it got to where it is today, all the actions that it took, all the input it got from the user, all the feedback that it got from tools that it called, all feeds into its memory and affects where it is today and affects what is possible in the future as it's trying to navigate around the information space looking for a solution. It's kind of a very simple metaphor, very obvious, right? But it's incredibly useful when you start to think about this for how you actually do work in the real world, in software, now not in the real world, in the software world, building multi-agent systems. Keeping this in mind is incredibly important. When people talk about context engineering, this is what it's all about. For a given agent that you're interacting with, and that is interacting with you and interacting with the world, what does it have available to it? And what is it trying to get done? And what nudges can you give it so that it heads the right way within all the possibilities to actually find its way to a solution space? This is something like information search, right? This is really ultimately what's happening here, which is good old, software engineering stuff that we all know and is GER proper engineering, not fluffy LLM prompt engineering stuff. Now we can start doing real software engineering with this in mind, framing how the agents do their work. This gets even more fun when it's not just a single agent, but there's multiple agents, so that you have to think about not just this one agent, what is its context, but its context is also a function of all the other agents it interacted with in the past that have their own memory and their own cones, right? And then also the ones that it might interact with in the future, which might be the same ones or not. And so how does all that correlate? How do you actually manage all that stuff in a coherent way that makes it the most efficient and most likely and most correct to actually find a solution to whatever the job was at hand? So let's think about the memory for a second and focus really on that, because this is where most of the problem is in the future facing part of it. It's like trying to take advantage of the memory you've got, what you've been exposed to and what's possible to navigate the future. So let's think about the memory for a second. First, in the kind of the time scale, there is what I would call working memory, and people tend to step right over this when they're talking about memory because they want to go into cognitive models and they're thinking about like how your brain works, forgetting that within an agent, the smallest part of memory, the smallest memory that has to be managed is the context, of course, window, which is on the transformer itself, which is how all the attention mechanism works. What the attention mechanism is paying attention to is working memory, right? So the tokens that it has seen, the tokens that it thinks might come next are all based on those relationships. That is its working memory. So your job as a software engineer is to actually add to that working memory so that its next token prediction gets better and better as you proceed. So you've got working memory, which is really the LLM's context window. That is what context engineering is all about. What's available for context engineering is tool calls that you can make, of course, and things that you've already done, which is short-term memory. So I'm making a distinction here that isn't really probably fair for neuroscience, but is, I think, much more useful when you're thinking about working with agents. Working memory versus short-term memory is a little bit different. Short-term memory ends up being the conversational history, either all of the conversational history or the parts of it that are relevant for what you're trying to get done now. Because again, the goal here is to provide just the right context. Actually, you're still doing context engineering. Find within the memory that you've got available to you the transcripts of the information that are there, the topics that are there, and like what the agent needs to know right now for its next step. So short-term memory ends up being used for that. Typically, that is kept just in RAM, but of course that can be persisted as well if you want to. There's no constraint on that. But the point here usually is that for the short-term memory, this ends up being high-fidelity memory. This is almost always like, give me the full transcript recently about this stuff is the most useful for this, right? Over time, though, of course, short-term memory becomes long-term memory. This is for sure persisted memory. It is no longer bound by just session state. It is across multiple sessions. And you want to keep not just the full transcripts, but if you keep the full transcripts of everything, that grows very, very large. And similarity search ends up breaking down over time as somebody says the same thing a million different times. You get high hits for things that are very, very similar, but not particularly useful. So long-term memory ends up being helpful if it is both full transcripts, but also nicely structured as well. So that memory retrieval is a bit more, and now I will dabble in neuroscience, a bit more like our long-term memory, where we anchor on key points. And then from those key points, we actually reconstruct a memory we had of our childhood or some place that we visited. It is either temporal or geolocation or topical, smell-based, things that anchor what we know, and we kind of recreate memory around that. For some of us who are lucky, you have photogenic, memory. You can actually pull back, full visual scenes of things. I don't have that, so I don't know what that's like. So I don't know what that experience is like. That is not any part of my modeling. But so this is the first thing that we've got to do. This is the same as we've got to do for any other kind of software engineering, figuring out what we want to keep in a cache, what we want to put into long-term memory, when we want to eject things from the cache. All those same kind of techniques apply here, even though now we're just calling this memory, and it seems like it's fancy because it's part of AGI. This is just software engineering at this point, which is really great. Okay, persistent memory across all sessions. The other dimension is really the space dimension. And here the space is both the space of the single agent expanding. Oh, sorry, hang on. I had some problems that I want to walk through first. So in just the scaling challenges here that we've got, whether it's the short-term memory or the long-term memory, you've got to deal with context engineering. This is the domain of context engineering, from what's available, what do we stuff into the context that's there now. Along the way, because you've got context through time, you've got to do reconciliation about facts. Like today I liked pepperoni pizza. Yesterday I actually was pretty happy with hamburgers. Hamburger pizza, in fact, as well. So if you ask me like what kinds of pizza do I like, or if you ask the agent that, what should it respond? It's got many options. It somehow has to reconcile that. It has to know about time to actually be able to reconcile that. You can do that at compute time. You can have data structures that help you compute that. Again, all the usual software engineering techniques apply. You can take advantage of software structures that help you reconcile things through time, or you can just do it, brute force and just manage it at compute time. In addition to managing it through time, like have opinions changed? Is this the same, thing that I'm talking about? Actually, what's this good one here? Oh, yeah, I was just watching, Is This Cake or Is That Cake? What's this show called? Is It Cake? No, just simply Is It Cake? Do you guys know that show? Mm-hmm. So it's a TV show. It's a baking show where contestants bake cakes, and then other people have to decide whether the cake that they're presented that looks like it's a laptop, and then they have other things that are laptops, they have to pick out the one that is a cake rather than the ones that are actual laptops. So that's the challenge. And one of the challenges when the people were trying to pick out which one was a cake, one of the people who were trying to work as a team said, just pick one, just pick one. And what they meant is just pick any one. But what registered was okay, we're gonna pick item number one, the laptop number one. So that went in as their final answer, which of course was a simple semantic misunderstanding, but easy to make. That happens all the time throughout text. When you say things within a particular context, and the word itself has multiple meanings depending on who said it, when they said it, what the whole context around them was. So that is very challenging, even just within this setting as well. That's something you got to pay attention to. So both entity reconciliation and conflict resolution, they're very similar, but in either time dimension or just context dimensions. And then the provenance is part of this all the way down. That if you want to be able to do auditing on this stuff, when an LLM is actually giving responses, it matters who said what and when. Sometimes you want the authority that really matters, not just that there is an utterance somewhere within the text or within the structured data, even if you have that as well, that says something. You care who stated it at what time. All these things just within managing what I'll call simple memory. For single agent, there's that. The other dimension is the space dimension for me, which is really about scopes of not just single, but multiple agents ultimately working together and what that looks like. Starting with a single agent, that's basically just all the concerns we talked about now with working short-term memory and long-term memory. This is just expanding backwards through time, really. Okay, put it into archival storage, however you want to manage this. There's lots of different techniques. When you get to a multi-agent, things get a little bit more interesting. As soon as you have multiple agents working together, you've got to decide how much do they share. Do they share the entire conversational history? Do you fork the conversational history, have things working in parallel? If you work in parallel, how do you reconcile them again? It's the kinds of things we do in software engineering all the time, but now on a data level, we have to decide forking data, merging data back together, obviously reconciling differences and all those things come along the way. So just with a single multi-agent system working within a single process, this ends up already being very challenging. You've got to decide what scopes should be shared. Is it short-term memory, long-term memory, and how are you actually going to manage all that? Lots of different options here. This is, I guess I'll mention some of the problems in a minute. It gets even more fun when it's multiple agents, but multiple distributed agents. This is the closest for me of like, this is kind of my happy space as a database guy, because we care about distributed systems and distributed data systems and things like that. So distributed multi-agents have a challenge with what is truth, which of course is something you turn to a database for normally. So now you have to decide scopes of truth, again, whether it's short-term memory, long-term memory, but also whether there's multiple groupings. These agents get to know this, those other agents get to know that. This gets very complicated very, very quickly, as you can imagine, which is why most people start with just a single agent and maybe some MCP servers and just have at it. The reason to go down this path and the reason for all this complexity is optimizations. You go down the optimizations route because if you've been building any kind of agentic systems, and a quick show of hands in the room, who's building agents? This guy. Who's been doing RAG? A few more people, 2 more people. Okay, so shall I give a quick background on these things? Really quickly, we've all dealt with ChatGPT, right? And you to talk to ChatGPT about anything at all, and you can ask it questions about the world. It's really, really good. But if you ask it questions about yourself, it has no way to know anything about you, right? So you've got to provide information about yourself. Part of the way you provide that is just by chatting with it. It has some memory built in, and so it remembers things through the chats you have with it. If you want to give it information about like the company you work at, you can't just tell it all those things directly. So of course you make an API call for that. So if you're building a system, you can use ChatGPT, call to your enterprise system, get some data from there, and pass that data over to ChatGPT for answering questions that it otherwise wouldn't have access to. So what's a good topic? You're working in medical. So which has got all kinds of access challenges, right? So you're not going to just hand ChatGPT or any other model. You're not going to just hand, here's a bunch of patient records. Here, do some work with this. That's going to be a terrible idea for many, many, many reasons. So you want to give it the least amount of information it needs for actually doing the work you're actually asking it to do. And this is what's called retrieval augmented generation. You retrieve the right amount of information, you hand that to the LLM, and then let it provide an answer for whatever question you just asked. That's the shortest thing I'll give. The kind of elaboration of that is taking this idea of RAG, making a call to an LLM, after making a call to some API. The elaboration of that is just put that in a loop and just let it run a couple times, so that rather than just making one call to the LLM, make a call to the LLM and say, hey, I've got a question. By the way, here's some options you've got for how to answer this question. You give it some functions, basically. Here's some functions you can call. You can either answer the question directly or you can use these functions. Those functions end up being themselves either calls to APIs or call to a database or whatever you might have on hand. Running that in a loop is the essence of an agent. Along the way, you maintain state, which is what is memory all about. Memory is just state for an agent, running in a loop, calling out to APIs. What you'll find if you go down this path is you end up giving the agent more and more tools to work with, and you give it longer and longer instructions about how to use those tools and how to achieve its goal. And just like good software engineers, you'll realize at some point you're getting worse results rather than better results because you've given it too much responsibility, and it's losing focus, and it's getting confused. And so you try to give it less things to do, give it fewer tools and fewer instructions and fewer responsibility by splitting it up into 2, and then 3, and then more agents so that you end up with a multi-agent system. This is how you end up down this path that I am down that led me to these things about memory. Looking around the room, does that very quickly make sense? Happy to talk more about any of those details. Okay. Imagine all that, but now put into a distributed system, and it gets completely insane very, very quickly. Trying to manage reconciling all the facts, all the things you record over time across a multi-agent system. So here's some of the challenges within this sphere, and I'll wrap this up because I know I'm close on time as well. This is still all about context engineering. You want to know who knows what and when. That still really matters here. What matters also across multi-agent systems, particularly if they're distributed, there might be different memory systems behind them. There might be different systems behind them. You don't know. Even if you're control of the system, you might be in an enterprise where there's multiple people who are working together across the enterprise in a multi-agent system. There are some people who are crazy enough to be doing that today. It is very, very hard. And one of the first challenges, how do we actually have the same representation so that all the different systems can agree upon what the word, one means, right? Choose anyone or whatever. So that it gets up into language, the terminology that you're using, the vocabulary that you have, the format of the data, of course, the values and all those kinds of things as well. And as a database guy, this is my favorite challenge amongst all of the challenges, because we already have a distributed consensus challenge within databases. If you have multiple servers up and running and people are writing to all the servers at the same time, how do you make sure the entire system agrees on what the value of any given record is, right? Or a field within a given record. That's already hard in a system whose intent is to be agreeable and to have a common goal. In a multi-agent system, it is very easy to have agents that are just slightly misaligned. That overall, because you've controlled them all, they have the same intent, but they have different goals that they're trying to achieve. And so they may not have the same desire for the same state. They might have different opinions about what is true. So this is basically ending up down the path where we have still a distributed consensus challenge, but now with throwing in the fun of having the prisoner's dilemma. Prisoner's dilemma, which is when you've got, actually this is a multi-party prisoner's dilemma, but the basic prisoner's dilemma is you've got two people who've got the choice of either working together or working against each other. And you score them based on whether they both decide to work together, and that's, I think, like 3 points or something. One of them could decide to work together, the other could decide to work against them. And I think the one who works against them gets higher points. But if they both decide to to work against each other, nobody gets any points. Something like that. I'm going to forget what the scoring is like. But it's basically a dilemma of like, do you try to cooperate and optimize your score through cooperating? Or do you try to not cooperate and try to guess when the other person is going to be exposed and you can actually take advantage of them? Over time, if you run this for long sessions with different strategies of having when to do what, it turns out that if you don't know how many turns are involved in the prisoner's dilemma, that most strategies kind of like settle out at being the mostly cooperative. The mostly cooperative is the best for everybody, which is of course a very socially nice thing to end up at. And being strategically kind of ill intent does not work out for you over time if you don't know when it's going to end. That it's most likely that probabilistically you're going to end up losing more than you win. Anyway, that ends up being embedded inside of a multi-agent system that is trying to have consensus. I'm going to leave it there with just this little bit here, which is, this is a very hard, all these problems are very, very hard. This is a very fun thing for database people to be working at. You can build this stuff yourself. There's really great papers out there. People explore all the cognitive models. There's really great open source projects that are out there for doing memory. They all start very, very simple and then slowly over time, unavoidably get more complicated because these are things they have to deal with eventually. You can build it yourself. We're going to try to build it as well. We're going to build it in an open source way. And I will be talking more about that as we have things to release. That's me for today. Oh, yeah.
So, do we have any questions in the room? Any questions on vJUG, feel free to type them in.
Well, thank you for the great session.
Cool, great. Oh, you have a question?
Oh, we have a question.
Yeah, I've got one question. So, what I was wondering is, as we obviously continue to expand systems with, like, obviously multiple AI agents contained within them, are there already established patterns for preventing essentially one, if not multiple, agents from hallucinating? Because what it feels like to me is the more agents you put into a system, the more likely probability that, obviously, with the effectiveness of them, that one of them is going to hallucinate something, the other it's going to go wrong, and the output will be thrown off massively, which obviously in a multi-agent system being a lot more expensive than a singular multi-agent, it's just costly.
Yeah, so there's a few answers to that. So first of all, multi-agent systems actually don't need to be more expensive. One of the reasons you go down a multi-agent path is because each of the agents can then have, again, less responsibility and have more focus on what they're doing. And part of the realization of context engineering is that even though context windows are growing, and God knows that at some point we'll have like 1 million token context windows or something, it is still the case that because it is a probabilistic system, the more you put into the context, the more opportunity you have for going wrong. So that the less you can put into the context that is necessary for answering a problem or taking the next step, the better. Even with the best models, it is true today. So multi-agent system helps you do that. You get to break down the problem so that any given agent has only what it needs to do, does not have full conversational history, doesn't have all the world available to it. Say, hey, your only job is to decide whether to go left or right. So the worst it can do at that point is pick the wrong path. So maybe it's 50-50. But if it's only got to do those two things, if that's the only choices it has, and you've given it good instructions, it is less likely to screw up than if you had to choose left or right, but that was after doing a bunch of other things and then getting to there, because all that other stuff is basically kind of poisoning the context for things that are unnecessary for that particular left or right decision. So it ends up being more efficient and less likely to hallucinate. So multiple agents is actually, for me, the most strategic thing to do to actually reduce hallucinations overall. And then it can be more expensive in this particular way, I guess I should say. If you take the extra step of for any given agent, you can then do something like what's called a LLM as a judge. We have one agent that basically comes up with an answer, and then another agent that criticizes it. And when we go back to the ChatGPT experience, for sure we've all done this where you ask ChatGPT something, and it's not quite right, and you just say, hey, I think you're wrong. That's all you have to say. And it'll actually be like, oh, yeah, you totally caught me on that. I am wrong. And then it'll rethink it and redo it. So you can do that on the agent level as well, but that ends up being more, calls up to the API, that ends up being more tokens, that ends up being more expensive. But that little act as well reduces the likelihood of hallucination. So it's a trade-off between how much hallucination is okay and cost. The other way you can save some cost is once you get reduced responsibility for a particular agent, we have the opportunity to go from a very expensive large model to a very specialized small model. And for sure, I recommend having some experience doing that, like just kind of messing around a little bit. There's plenty of small models, plenty of open source. Try a bit of fine tuning, and you'll be surprised how easy it is to get a little bit better results with just a local model you can do. Out of the box, it's gonna be terrible. But with a little bit of help, it can actually do pretty well. It'll be faster, cheaper, and then, yeah, I think a good solution. Cool. Okay.
Any other questions in the room? If not, can we have another round of applause for that?
Thank you.
All right, so we straight on to the next speaker, Sam?
Yeah.
Yes, and that is? Simon, I know some colleagues that are looking forward to your talk, so hope you do justice.
Cool, thank you. Okay. Oh. Hello, everyone hear me okay? Hands up if you can hear me online. Someone's doing it, someone somewhere. Cool, so I'm not sure exactly what session I put down in the abstract. I think there's a different demo that I'm giving from what I heard. I'm not sure if this is the same title, but this will be a cool session on a very, very similar topic. So it's going to be cool. This is all about spec driven development and how we as developers can use specifications during our development with agents. Today, there's quite a bit to get through, actually. I gave this session at DevOps last week. It was a 50-minute session, and I realized about a quarter of an hour beforehand this session that it's a 30-minute session. So we're going to go, no, we're not going to go twice as fast. We're going to, I've cut a few bits out, but check out also the DevOps Belgium recordings if you wanted to see the full session. We're going to talk a little bit about how coding agents and assistants have changed, and talk a little bit about some of the prompting lessons that we've learned in building testable, which I'll show a little bit and talk a little bit about. But ultimately, there are problems with prompts and things that we need specifications for in terms of, breaking into that next area of more predictable, more production-ready software development with AI. And we'll talk about spec-assisted and spec-driven development. So let's jump straight in. Actually, a quick show of hands. Who's using things like Copilot today, or has used Copilot? Cool. Cursor, those types of things. Windsurf, equally. What else? Maybe some CLI things. Yeah, Claude Code, or Codex, or what's the other one? Amazon Q as well. And what's the other one? What am I missing? Bob AI. Bob IDE. And what was the other one? It's Gemini CLI, anyone? Maybe a little bit of trying. Okay, cool. So we're going to talk about assistants and then agents. So when we think about assistants, we're really talking about things that have short time frame in terms of helping, very chat-based, where I ask for something small, it does something small back, and then we kind of like repeat. I would expect an agent to do something greater, like maybe call other agents or call other processes, do more work, the time span, be more asynchronous and more autonomous. An assistant, or something that is very much more chat-based, the original kind of thing that I absolutely tried myself, certainly when thinking about how code can be built, is ChatGPT. I'm sure most people started here, where we just tried to say, okay, try and build this thing. We copy-pasted it into the IDE, copy-pasted any errors back, and we continued and iterated through. We were probably all just as amazed at how the heck is this actually doing this thing. But of course, the UI wasn't very good because we have to copy-paste. We're not as aligned in our workflows. Then, of course, GitHub, I should have put GitHub here, but GitHub Copilot was introduced, and this was a similar kind of style of LLM in the background, but ultimately making those changes directly in my IDE for me so I don't lose my context as I type, whether it's comments or changes to my methods or functions. It makes updates for me. And this has, of course, progressed more and more into a more agentic workflow within GitHub. But there's a few others that kind of like after this, everyone went, right, I want my own agent or I want my own tool. And a million kind of tools were launched at the same time. Some of the tools that I kind of mentioned with things like Cursor and Windsurf and things like that. Let me take you through a couple. This is Cursor, which is a VS Code fork. And as part of this, one of the big changes and I guess challenges that GitHub back in the day restricted us to was single file changes, very often single line or very few number of lines. One of the things that Cursor did, of course, was had this at the time, I think it was called Composer, now it's just called Chat on that far right-hand side. I can add context to that chat, I can provide a number of files, and I can essentially say, make this change across a number of files in my project. As a result, Cursor will go ahead and it will look at the various files that I've given it, it will look at my project structure, and it will say, okay, these are the changes I'm gonna make, and this is the set of files that I've changed. So for example, in this application, which is actually an application which was built way back when in Windsurf, I think it was, and I imported it into Cursor. This is a bit of a rip-off of SimCity. I think one of my colleagues, Joe, called it, oh, I can't remember what exactly he's called it, but it's something bizarre and strange. Tiny Town Simulator implementation, there it is. I've asked for a new building style. Okay, so make this change across my environment, across my projects. And it's done a bunch of things. It's very often these tools tend to create a number of to-dos and then they work through these to-dos. This structure very much helps LLMs complete more thoroughly. It works out what changes it needs to make to the various files. It'll go through and then it will say, okay, here's a summary of everything I've done. Here's the implementation details. And here are the changes that I have made across your files. As a result, I can then validate what has been changed. I can accept or reject. And this is super important when we think about, when we hear the term vibe coding. Who's vibe coded or is a vibe coder today? Who's willing to admit to that? So vibe coding, okay, typically where we throw some prompts in, it makes some changes. We may or may not even look at what it's done, but we can accept or reject based on our ClickOps. So I can click through and say, yeah, this looks about right. One of the things I like about things like Cursor is it connects you very, very much to the code. So I can see what changes have been made. I can validate, I can do that code review. There are certain tools, tools like Bolt and things like that, they'll do, or even, what's the other one? Base 44 acquired by Wix. They allow you to do things in a much more agentic way, whereby it keeps a lot of the code more away from you and shows you this amazing web app with just a single prompt, and it YOLOs this very often very functional and working web app. But of course, you're very significantly distanced from the code. It's a much closer vibe coding environment. So Cursor, I know a bunch of people in Tessel who use Cursor. A bunch of others use something called Claude Code. Many Claude Code users? Fair number. Okay, so Claude Code brings us back to the terminal. So this is Claude Code. Oh, it doesn't look great, does it? If I was to do that. Yeah, the screen's a little bit big. Oh, let's make it look pretty. There we go. So this is our little friend Claude Code. Version 2 is just out. It uses Anthropic's 4.5 Sonnet 4.5 model, trained still back in January, so a little bit old in terms of if you expect to use some of the latest versions in your training data. But ultimately, in this case, I just asked for a game of a CLI game of tic-tac-toe. I don't really need to say much more, and it kind of like goes ahead, works out what it wants to write, what it wants to build. Sometimes it will create a plan for the bigger environments. It builds, it chose Python here. It didn't ask me necessarily, but it creates a bunch of code, makes it runnable, says it's done. And actually, if I was to run this, I did this because sometimes it takes a little bit of time. But if I was to run this, I can now play tic-tac-toe against nobody, against myself. Whoops, 43, excellent. So I can, well, I'm not even looking. 6. No, they're both me. I'm going to win, Manny. There we go. I win. Player X, that's me. So yeah, it works reasonably well, but as soon as we actually push this too far, there will be a ton of various spaghetti issues that we could expect. But it's pretty cool for doing very, very little. Okay, so when we think about prompts, and everything that I've kind of like shown are just very small prompts with me allowing the LLM to make a bunch of decisions, there are certain prompts which our AI engineering team here in Tessel shared a number of learnings. There are actually whole sessions about this that we give. I'm just going to give you 3 that I found most interesting. One of the first ones is that LLMs start reading your prompt and acting on that data before they finish and complete reading your prompt. So as a result, they're starting to build up an amount of knowledge, trimming paths based on that start of your prompt. And it actually means that start of your prompt is super, super important. The second one is about the anatomy of a prompt a little bit, but in terms of, sorry for the XML here, but one of the things that we actually started in the early days doing is categorizing parts of our prompt through XML. You can also do so with Markdown and other things. But this ability to say this part is provided materials, this part is a Markdown specification, and so forth, doesn't just allow you to then refer to other parts of your prompt, maybe in future prompts and so on. But the LLM has a stronger chance, for whatever reason, of looking through this and actually providing a more accurate answer. So we found that we use that a lot, particularly in our specs as well, which I'll show you a little bit later. And the third is something called task framing, and this is pretty cool. So in this case, we asked for a self-contained JavaScript. Oh no, I gave the answer away. In this case, with task framing, we asked for a JavaScript package to meet the requirements of this specification. And at the very end, we had a constraint, which is do not use external packages. This is great. Now, there's 2 things that I'll say here. First of all, constraints aren't always the best way of giving our requirements. It's better to almost like flip that and actually make it a part of the requirement, which I've already given you the answer, but I'll show you in just a sec again. The second thing is we've obviously put it at the end. And so, as we know from our previous learning, once it's at the end, we're already constructing an answer before we even get to that end. So don't use external dependencies. 9 times out of 10, this will create us, and in our test, this pretty much always created a solution that did use external dependencies, because in its training data, pretty much every single solution was to use external dependencies. What we changed was to actually frame the task whereby the constraint is actually a positive. So in this case, rather than saying don't use external dependencies, we're saying write a self-contained JavaScript package. And the LLM, when it reads that, it understands very clearly it shouldn't use dependencies. So it's framing the task with the constraint, but not actually describing it as a constraint, and also making it very much top of fold for the LLM. Okay, there's a number of pitfalls that I think we as an industry have learned when we're using LLMs and LLMs during our development environments. And I asked AI, this is a nice little counseling session where I got ChatGPT on a little couch, and I said, right, you're not perfect, ChatGPT. Tell me all the problems that you've experienced when people are asking you how to write code. And ChatGPT said, I'll do it via pictures. I'll do it by the means, the method of the medium of dance and pictures. So it gave me this thing. It says, first of all, collateral damage. I'm sure everyone's seen this, where I have asked like Claude Code or something to fix one piece over, in this, part of my package. It does that perfectly, and it creates two other collateral damage style issues. Maybe it's behavioral, maybe it's using something from a different library, whatever it is. It fixes one thing, sometimes break others. The more complex we get, the more often this is a problem. Forgetful agents as well. This is very, very much a case when we have fairly lengthy sessions with an agent whereby we're asking it for different things constantly. And then when it sometimes regenerates, it goes, actually, I've forgotten point 3. And you realize because you say, oh, I asked you to do this before, and you're having to continually remind it about these various things. We all know about hallucinations. I'm not going to go on this too much, but APIs are the classic where it tries to hallucinate a method that doesn't exist or an API that doesn't exist. Very often, it's actually because when we look at an agent's training data, there are a ton of different versions of libraries that an agent needs to learn about. And so just because it thinks it sees a ton of examples on an API call with this method doesn't mean that method exists on the library that you're actually pulling in at the version in that package. So version blur is an interesting one. And training data, I mentioned, things like Sonnet 4.5, Sonnet 4, both trained January 2025. We have Spring coming out, Spring 7 coming out in November of this year. What chance do we have of an agent being able to code against that with no knowledge about that at all? And a lack of persistent knowledge. Just as we get to that point where we're priming our agent with a bunch of information, we close the agent's window or it crashes and we have to do the whole thing again. So every single time we use these agents, if we're not using things like specifications or more persistent information that we can share with it, we're having to say every single time, this is my style, this is how I would like you to do this. No, don't use that. I've told you that a million times. And this is the answer we always get from an agent. You're absolutely right. When I gave this in this session in Belgium, this dude at the front had "you're absolutely right" written on a t-shirt, which I thought was very apt. But we get this very much once per session. And then as soon as it says you're absolutely right, it always fixes it every single time, right? No, it doesn't. We get into this horrible loop where it just says, oh, you're absolutely right. Like, what an idiot. Why did I even think about that? And it just, for the same reasons as it got it wrong the first time, it can't fix those reasons. You're asking it to do the same thing with the same flawed data or not enough data, and you'll get the same result again and again and again and again. So how do we make agents more accurate, more predictable, more current, et cetera, without that frustrating, circular loop where we spiral out of control? Now, the way we think about this at testable is with specs. And the reason why we think specs are very, very good is because one of the issues when we think about pure implementation code is that implementation code couples the what and the how of an implementation. So for example, you've got a couple of examples here of how we can color a button. Both blue, they both do it in different ways. If we was to look at this, if we was to try and identify what are the important things from this file, because things can be done in different ways and we don't understand the intent of why something was done, we don't understand whether it's a required thing, whether it's just a decision that an implementation decision that a developer made. It can be any of these things. So if we was to try and actually understand what is important and what isn't and provide that to an LLM, it's extremely hard to do that with code. Specs care far more about the intent. So when we actually write a specification, it is the exact wants and the exact, very often, tests as well, or cases that we care about for an environment like an LLM to be able to build this specification. And of course, they don't just have to define applications. We don't actually have to just say, this is the application I want to build, here's a spec. They can actually help agents through a ton of stuff. So here's for example, we call this a usage spec, which is a React usage spec, and it provides an LLM with the context required to use React at a particular version. This is how you use it. Here are examples. Here's the API. Here are the methods you can use and what you should send to them. And it gives enough information so that the agent can then make a good decision when coding against it, and it provides fewer of those issues that I mentioned before. So I'm going to jump into some examples now. That is cursor. I don't need that. Let's jump in. Okay, I'm going to be using testable here. Testable is only just open beta. It's free. You're more than welcome to go and have a play with it. I'm logged out now, so I'm using it in an anonymous way. But I'm going to do a couple of things. First thing I'm going to do is show you, similar to that React example, something called a usage spec, how I can pull a usage spec down and allow my agent to use that usage spec as part of its development. So first thing I'm going to do is run testable init. And what testable init is going to do is it's going to provide my agent, it's going to update my local files. And in this case, I'm going to use Claude Code, and I'm going to set it up as an MCP server as well. It's going to update things like my agent's MD to tell the agent that these things exist called usage specs, that spec driven development is a thing, and that when it develops, it should try and search for information that it can use as usage specs to actually more accurately code against these different types of environments. And as usage specs, the way we build usage specs is, and they can be a number of different things, which I'll go into in a sec, but the way we build usage specs is directly from the actual code, as well as the documentation, as well as examples. So I'm going to run Claude, as I mentioned, and it will ask me if I want to use the MCP server, which I do. In this case, we're going to create a CLI app that sums the total number on dice. Use dice notation, i.e. 1d6. So this is one roll of a 6-sided dice. 3d20 is 3 rolls of a 20-sided dice, and so forth. Because this is a demo, and I believe in demo gremlins, I'm going to say use testable usage specs. I almost forgot the name of that. Okay, this is now, it chooses a verb if you haven't used Claude Code. First thing it does is it's going to read the knowledge MD. Knowledge MD is something that describes, it's a little bit like a package JSON, a POM XML. It describes what usage specs we have in the environment, same as the testable JSON. It's decided it wants to use Node for this. It's decided it wants to use something called Commander, which is a Node dependency that uses a CLI or that builds a CLI. It wants to search for a usage spec called Commander. I'll say, yes, you can absolutely do that. It's found 5 usage specs. It said it's found it. It's going to now install it. And by installing it, all it does is it pulls it down to the local environment. Okay, it pulls it down to my local file system. The only file I check in is actually my testable JSON or and my knowledge MD. It's going to create a package JSON. I'll let it go ahead and do so. I don't check in the usage specs. All I do is, when I want to use it, I just say testable install, and it will pull down all the usage specs that I need, all the latest versions of the usage specs I need. At this point, it's now creating diceparser.js, and it's doing that in such a way where, if I was to press O, it's doing so in such a way whereby it's using the information that I downloaded as part of my usage specs to be able to, and passing that in to the main agent to say, as you're building against this, this is how you do it. So it avoids a ton of those different things. So now it's doing the npm install. I might be able to get to a stage where I can actually just run this. Oh, it's running it itself. So it's doing a node index.js roll 1d6. And it's going to do that again because it didn't have, there we go. So the total was 4. So it's testing it locally, and it's doing a bunch of other tests. So it's doing 2d20. You must have heard me. I think I said 3d20, right? Oh, it's doing 1d6 plus 2d20. And it got 19 for the 2d20, which seems reasonable. It got 1d6 is 5. 2d20, 1 and 8 together. So yeah, this is a nice little way of actually using usage specs to guide my application. Now, the cool thing happens when actually we go beyond libraries, or certainly beyond open source libraries. What if I, as an organization, have a ton of closed source libraries? How is an agent ever going to learn that? Well, We can have a private registry ourselves. We can invite whoever we want to that. So as organizations, you can also have private usage specs that only your team or organization can use, and you can code more accurately against your own code. But why limit it to just libraries? You could actually say, well, I've got a cursor rules file. I've got an organizational styling guide. We can add anything as a spec. A spec is just a markdown file. And I'll show you it in just a sec. But a spec is just a markdown file. So we as developers can share our guides, our cursor rules, our policies, all these kinds of things, and provide that to the agent every single time we use it. Okay, the next thing I want to do, and I'm not sure if I'm going to have too much time left to do this, is I want to do a testable login, and that's going to say, can you click confirm? I'll say, yes, I can. And there we go. I'm now logged into testable. So now what I'm going to do, I'm going to say testable init. Because I'm logged into testable, I'm going to use the full testable framework. This is now me being able to create applications from specs. So now I can create a specification defining my application. I can still use usage specs if I want as well. And my application is then very closely paired with that specification. I'm going to use Claude Code again. I'll use an MCP server. I can run Claude. I'm going to use testable MCP. Now I'm going to say create a Hangman application spec. I can also say use usage specs if I want. It's close enough. It'll work it out. Okay. Now what it's going to do is, in fact, it's going to ask me a number of things. Yes, CLI, you decide other options. I can now say I'm going into a bootstrapping mode. This is us asking Claude Code to prompt how we actually create this application. It's doing a whole bunch of stuff, including reading knowledge. It wants to create certain things. And I'll get this up to the stage where I can show you a specification and what a specification looks like, because I think that's the important stage. A number of things that it might also do as well is it might create a plan, which is a very, very common kind of thing for agents to be able to do to break things down. It's creating a number of directories, in this case, a specs, a source, and a test. It's doing a whole bunch of initialization for me, including NPM in it. It might do some vTest in it as well. Yep, it's going to be doing that any second as well. It's going to create a bunch of config for me and things like that. And all of this gets written down as my agent's MD. So all my decisions are persisted beyond this environment as well. That's my TypeScript setup, my vTest config setup as well. It's now bootstrapping the project. What that means is it's going to ask me, what kind of application do you want to build, or it possibly will, depending on what stage it's at. It might ask me, what are the things that I want from this project? Anything that I answer, or it might not actually, because I asked it to do all the defaults. But at that stage, it's going to update the agent's MD. In this case, this is all the information that or the agent has decided upon, and it persists it. Project is bootstrapped. Now it creates the spec, and in this case, it should hopefully call testable, because testable will create the specification for it. There is the specification, and it's pulled all the information that I've given it, that it has decided, into that specification. If I go over to my VS Code and open specs, it will any second create that specification. I'll talk to you a little bit about what is in that specification, and then we'll move on. Now, a couple of things. When that specification is created, I can then decide whether I want to generate code, whether I want to add tests to it as part of the capabilities, and when I want to actually build those tests. Because when I build those tests and I run those tests against my code, I'm validating that my code and my spec are actually in line. That's the core piece. We don't want to see drift between my specification that gets created and my it's already created. Let's see it. There it is. Between this specification and any code that gets generated. So I'll go through a few important pieces of the spec, and then we'll jump back into the presentation. So as part of the spec, we have a light description in terms of what the application is. We have an @generate, which means we're going to be generating code from this specification. You can also have specifications that describe code. And the reason we might do that is if we wanted to share context. We have a list of capabilities, and these turn into tests. Every capability I have here will become a test case, and that's how we validate code to the specification. A whole bunch of capabilities. And then we have an API. What does this look like from the outside so that others can use me, others know how to use me from this specification? Okay, I won't go any more into that. I'll just jump through a few final slides. If we go back and actually look at some of the problems, sorry, this title's actually wrong. If we look at some of the problems that we had before, we tend to not get the collateral damage because actually all the issues, or rather all the things that we care about and that we want to describe are listed in specification and have associated tests with it. So long as we get that validation and tests will run as we change the spec, we can be sure that the specification is being adhered to by the code. Secondly, we don't have that loss of instruction because, again, everything is line by line described in the spec and associated with tests that we can validate. We tend not to get hallucination through usage specs because every open source library or private library that we're using can have an associated usage spec at that version of that package. And as a result, we can code right up against that library with the right input. Version blur, because I mentioned a usage spec has a specific version. If I'm using, version 6.1 versus 6.0, I will absolutely have the usage spec of that version for that package, and I will code against that API. So we don't tend to have version blur. Training data for the model still can exist in January, but if I have usage specs, they can be up to date, and I can pull them every single day as I wish. And everything gets persisted into markdown files that I can use when I want. They can be checked in alongside code and reused by my team. So the persistence very neatly occurs as well. So a lot of the issues that we're trying to find, a lot of the issues that we're trying to solve are some of the core issues that we've been having ourselves with agents, and that's what we're trying to fix. So yeah, we are at testable working on answers to a bunch of major questions that exist in the spec space. I have no idea where that QR code goes. I'm not going to lie, but feel free to scan it. And Sam knows. Where does that QR code go, Sam? It does. I don't know if there's any codes or anything. It's just a wait list. Okay, feel free to scan that if you wish. That's for the closed beta, which is the framework. The open beta piece is everything in usage specs, which is available now. You can use it with no authentication and just go and have a play. I shall wait until there are no... Oh, there is actually some QR codes on a couple of screens here as well. So feel free if... I'll give it a few more seconds. Bap, you work for testable. There's no reason you should be taking a photo. You're wasting everyone's time, Bap. The community, Sam's already mentioned that, but feel free to join AI Native Dev. And that's me. Thank you. I don't know if I have time for questions or...
Yeah, I've got a few minutes.
Yeah.
If you can repeat the questions in the room.
Yeah.
We've only got one microphone. That's
Sure.
amazing. So any questions in the room? Yes, I see one.
Does it know all games in the world?
Does it know
All games in the world. So you ask it.
Claude Code generally?
Ask it to write.
I mean, it knows. So yeah, I mean, the thing about large language models, you get two different types. You get very specifically trained or you get generally trained models. There are some companies like Poolside is a good example that are trying to build specific language models whereby it's trained on code specifically and not other things. The nice thing about an LLM that is more generally trained is if you are trying to build something and you say, hey, I'm using make some more noise, Sam.
Could you go that way?
Yeah.
Perfect. And I'll
Oh
switch
yeah, go for it. Oh no worries. When the hook comes and I get dragged off, that's when I call. So I think it will know everything that is generally available on a ton of different internet sites that it trains from January. So tic-tac-toe, chess, all those types of games, when there are basic rules that are common knowledge, it will know about it.
It means that it cannot write specification for any new application.
No, you can. You can write a usage spec if you wanted. and then use that usage spec as context for your application, or you can just build a completely new application using a specification. And that's one of the core things that is super valuable for usage specs. It doesn't need to be part of the training data. You actually add it onto training data afterwards. Your hand's up first, sorry.
Would you say that this method of obviously generating code is less friendly towards exploratory projects? Because to me, it feels like, for example, just to give you a very specific example, I was trying to install some form of a server on like a little ARM computer, whatever, and I needed to find the right, compiled bit of code for it. It sounds like a lot of that legwork that I would normally, if I'm just exploring something, could rely on AI to do for me. Now it feels like I have to do that legwork myself in order to compile that specification code, in order to have that write it for me, which I feel like it was the exploratory aspect of AI a bit.
Yeah, no, I mean, I would say, yeah. Does the exploratory nature of development, as we want to kind of like build things ourselves, is that lost when we need to go jumping in straight into spec writing and things like that? I actually don't write specifications, certainly from scratch. I don't write specifications from scratch. I actually do a lot of my exploratory first. I do a lot of exploratory through AI, and then at that point, when I start knowing what I'm doing, I will then go in to start writing a specification. So in the same way as like doing code, I wouldn't just jump straight into code without doing that exploratory piece. I would start with the specs at that same point of when I'm ready. So I don't think it kills that exploratory. In fact, I think AI actually massively helps with that exploratory piece because it does a ton of the legwork and actually points me in the right direction for where I need to go. Yeah.
We've got one question online.
Yeah. How much time do I have? I don't want to.
How long we got?
Let's do one more question.
One more question. All right. We'll do.
The live stream one.
Okay, I'll do the live stream one. So the question is, sorry if this has been covered. How have you found spec-driven development in existing applications? Significant advantages versus agent instructions?
Yeah. Do I need to repeat that for those online?
No. Well, yeah.
I'll answer the screen.
Okay. Yeah, so brownfield projects, yeah, absolutely. You can, so at Testable, we have something called Testable Document, which turns code into specs. I wouldn't go Testable Document to turn code directly into specs and then expect me to go the other way. It's a bit like if you ever gone into Google Translate and say, turn this from Japanese to English and then back to Japanese. No, that's a bad example. Turn this from English to Japanese, then back to English. And you will very rarely get the same thing, right? Because there's a ton of extra decisions and context and things that gets lost. So you can absolutely use specs for converting from existing code to specs. I find it most useful for when then giving that as context to agents to then make further changes to my code. So I can use it in more of an agentic way to be more accurate. That's probably where I'll suggest that.
Thank you.
Awesome. Thanks very much.
Round of applause for Simon, please.
My laptop's somewhere over there, is it?
Yeah, Simon's going to be around. If you've got any questions in the room, please. And without further ado, we will now introduce my last speaker, Holly Cummins. So round of applause, everyone.
Thank you very much. Hopefully we've got audio. Audio?
Can you hear Holly? Yeah.
Excellent. Hooray. So I'm going to be talking about making your apps smarter with LangChain4j. So we're sort of going a bit back to basics, but also a bit in a different direction from Simon's talk. Let's go right back to basics and start by talking about large language models, which are the sort of the basis of all of this. I think intellectually, we all know that a large language model is just a stochastic parrot. It's just probabilistically selecting the next most likely token based on the previous tokens, based on what it's ingested from the internet, and it's just regurgitating that back. And yet, in practice, of course, it doesn't feel like that at all. It feels completely magic. So if I want to take advantage of that magic, or if I really want to sort of actually make that magic useful, what's involved? There's a whole bunch of people who most likely are not us doing a lot of work to get that magic to us. So at some point somewhere, someone's going to be training the model. And then at some point, they're going to be using maybe something like Kubeflow, maybe something else to get that model deployed through to production, and then they expose it to us with a REST API. But that REST API on its own is sort of limited use. You know, we don't want to be doing all of our AI interaction with curl. If we want to use LLMs in applications, we want to use that output in our code to make our application smarter, then we're going to need to obviously use that output, integrate it into our application. We're probably going to be looking at multiple models. All of those models have their own APIs, although they tend to now somewhat standardize on OpenAI as well, and they have their own way of structuring their prompts. And probably what we're going to want to do in our application is switch from one model to the other, because we might do the sort of the standard scenario of starting with Ollama because we want to make things cheaper, and then realizing that the application is producing complete nonsense and giving up, and then going to OpenAI and then getting the bill, and then going back to Ollama and thinking maybe if we change the prompts it will work. So, you know, we want to have that flexibility in what model we're coding against. And of course, the other thing that we really need is we need memory. When I interact with ChatGPT, the reason it is somewhat coherent is because there is memory in the browser window. If I go in through a REST API, that memory isn't there. And so then what I'll get doesn't really make a whole bunch of sense. So I need to have some way of passing through context in with my prompt, or it's chaos. So obviously this is a fairly old problem, this need for these higher level structures on top of the REST API. And a project called LangChain did really nice work to solve these. And so what I'm going to be talking about, I'm not going to be talking about anything below the fold there, all of that REST API training the model, that's data science stuff, not for us. And I'm also not entirely going to be talking about LangChain. Because although LangChain did really nice stuff, nice work to allow us to leverage LLMs in our applications, there's a really big problem with LangChain, which is it's Python. We are not Python people. This is the London Java community and the virtual Java user group. So I think I can safely say that none of us are in the Java user group because we secretly want to use Python. We want to use Java. And in fact, there's really good reasons, even if we weren't attached to Java because it is better than Python and because spaces don't have semantic significance, which is obviously the right design decision. We have so many assets in Java. We have so much collateral of applications that we want to be able to smarten up. So we don't want to be switching everything to Python and having this sort of Python layer that's sort of trying to like integrate to our Java applications. We want to be able to do the things that we're doing, but just also taking advantage of LLMs. So a chap called Dimitru realized this problem and he said, LangChain, very cool. Only problem with LangChain is it's not for Java. So he wrote a variation of LangChain. It initially started as a port of LangChain to Java. Since then, I think he's gone actually further than the original LangChain, and he's made some really nice decisions and added some nice capabilities. So they've pretty much diverged now, but the name is the same. I'm going to be talking about LangChain, but the reason LangChain4j is so useful, I think, is because if I have an LLM, for that LLM to be useful, it can't just operate in isolation as, you know, a little chat window that sort of has no access to data. For my LLM to be useful, it has to be able to take advantage of the data that I already have in my organization, interact with that data, interact with those systems. It has to be able to read and it has to be able to write. And of course, this is the kind of stuff that we do in the Java world for ages. This is an integration challenge. And I work for I work for Quarkus. I work on Quarkus. I work for Red Hat. I used to work for IBM, except now I work for IBM again. It's quite complicated. Please don't ask. And so, this is both Red Hat and IBM. They're so good at integration, and there's so many other frameworks as well. Integration is something that Java is amazing at. JSON parsing, maybe not so much, but integration, we really do this really well. So this is why something like LangChain4j makes a lot of sense. But it is also why maybe, even though LangChain4j, a lot better than LangChain because it's not Python, maybe you want something on top of it as well. So as well as all of those capabilities with LangChain, I'm going to do a demo in Quarkus. And there's a couple of reasons for this. One is because I work on Quarkus, I know Quarkus. But the other is because it actually does add some nice capabilities on top of base LangChain as well. So things like easy access to data, dependency injection, annotations, all of that is something that you're going to get with a lot of Java frameworks. But then if you want something like live coding, failover, that kind of nice integration with mocking frameworks, all of that is something you're not going to get in the base Java, and you want maybe a framework on top. And of course, if you're going to be taking this to production, you're going to need some observability. And this is all stuff that we know how to do in Java, that we know how to do in our Java frameworks, and we can just bring them in. So that's why I'm going to be talking about Quarkus LangChain4j, building on LangChain4j. But hopefully I'm not going to be just talking, because that would be a lot of slides. Let's do some coding instead. So, no matter how many times I set up my desktop before I do a demo, it's always slightly in a different arrangement when I actually do the demo. So I'm going to go to code.quarkus.io, set up my application. I'm going to do a web app, and I'm also going to add in some LangChain with it. So you can see there's a whole bunch of extensions in Quarkus that relate to LangChain, that have integrations for various models, that have somewhere in here, there's like an agentic LangChain. But I'm just going to do normal OpenAI. So I'll just type OpenAI, and then I can do LangChain, OpenAI, generate my application, and let's have a look. So in my Finder, I've got my application. Let's just open that in my IDE. And then somewhere over here, my IDE is going to start, hopefully. Okay. So I've just got normal Java Maven project. In here, I have my greeting resource. So far, so hello world. And oh, that's really exciting. I have just shared my OpenAI key. I've cleverly set it as an environment variable, and I did it wrong, so that every time I open a terminal, it exports it. So hopefully there will still be some credit on that account by the time I get to the end of my demo.
It's on YouTube, don't guarantee.
Yeah, time to do some key rotation right now. Okay, so I've got Quarkus started. Let's bring up my application. And so I've got just an application here, and I've got a hello world endpoint. So far, no OpenAI. So what I'm going to do, because again, what I'm trying to do here is I'm trying to integrate the large language model to my application. So I'm going to use dependency injection. So I'm going to inject, and I'm going to inject a smart greeter. And then instead of having my hard-coded string, I'm going to get my greeter to do the greeting. So greeter is a new class, so let's make that. So what the sort of the basis for the integration is an annotation called register AI service. So if I define an interface and then put register AI service, then I'm hooked in to LangChain4j. So I need a method. So I'll do public string greet, and I will take a name. And so with that, now if I go back here, let's hard code a name. And so then now, if I go here, then I don't have an API key. Luckily, about 8 billion people now know my API key. So it's okay, I can put it in. So if I go, whoops, if I go to the dev UI, oh, no, I can't because I don't have an API key. So if I go to my config, I can in here, I can define a key, and then I can say it's my OpenAI key. I think it probably should be OpenAI API key. So then if I go back to my dev UI, it's good. And so I can check things are working. So in the dev UI, I've got a tile for every application, and I can just chat. So I can say hello. And this is just a useful debugging tool. So here I have just a chat window to OpenAI. But of course, I don't want a chat window to OpenAI. That's exactly what I'm trying to get away from. So let's go here and let's look at what my application is doing. So if I do that, then I should get, so I've got, so I have, you'll notice I had very little in here. I had a name, and just based on that name, of course, the prompt is going to work out what I was probably trying to do. But I can do a bit better. So I can define a user message, and I can say, hello, my name is name. And so you can see I've got the parameter templating here from the method. And then if I go back to my greeting resource, I can put in a query parameter and call it name, and then say string name, and then stop hard coding Holly, and I can say name. And so then if I go back and look at my window, if I try this now, I should probably get like a null or an undefined or something, because I've used a query parameter. Oh, yes. Hello, my name is, seems like your name got cut off. So we can fix that. So we can say name equals Fred, and hello, Fred. So probably I don't want to be having an application that just has a user message. I probably want to have some kind of system message as well. So let's define a system message and say, you are a professional greeter. Say hello in French, no matter what language the user uses. And so then going back here, oops. If I do hello, we should get bonjour. So this is starting to get kind of cool, but we want to do more, of course. So let's have a look at tools, because so far, you know, I'm not bringing anything from my actual application to OpenAI. I've just got a slightly fancier front end to it, which is just a REST API. So what I'm going to do is let's make some extra endpoints. So let's change that to API, and then let's change that to hello. And then let's make a new endpoint which is telling the time. No arguments. And change that to time. Ooh. Change that to time. Then if I go back here, right, let's let it make that. And then let's give a system message. Give the user the current time. And so if I go back, and if instead of doing hello, if I do /API/time, we should start to see the sort of the limitations of just the base LLM, which is, it seems like magic, but of course, it can't tell you the current time. It has no idea what the current time is. The closest thing it could give you to the current time is, sort of January 2025 or whatever, which isn't at all what you want. So what can we do? So this is where we can start using tools. So I can here say tools equals tools.class. And let's make that class. And back here, it dropped the suffix. So in my tools.class, this again is where I sort of start to hook into all of the micro profile goodness that I already know. Because I'm going to make this just a normal bean. So I'm going to say this is a CDI bean. It's eligible for injection. It's application scoped. And I'm going to make a method called public string time. And I'm going to say return local time, not. And so now what I've done is in my smart greeter, I've said, hey, should you get something that you don't really know how to deal with, here's a toolbox that's available to you. Here's the class of the things in the toolbox. And then if I go and if I look at my dev UI, let's turn on some logging. So in my configuration, just going to log the request and I'm going to log the responses. And then I'm going to hit my time endpoint again. API, thank you. This is how you know it's not recorded. This is how you know it's not recorded. So let's have a look at our logging and let's see what's going on. So you can see when you start to log the requests back and forth, how much stuff it's passing on every REST call to the LLM, which is why you really want some framework to help you with it, not just to be trying to do it. So this is the response that's come through. And what I would expect to see is, so there's my system message. And there is nothing in there about tools. So it should be saying, hey, my system messages give the user the current time. Here's a toolbox that's handy. So now what we're going to do is we're going to do what anybody would do and cheat and go back and look at the other version, which is exactly the same. Nope, so that's not going to help us. So let's look at tools. Okay. It may be that because no, let's go back and have a look. Oh, did I completely forget the tool annotation? Oh, I completely forgot the tool annotation. Thank you. Yeah, so you don't need the description. Obviously, sometimes it's useful, but it will figure it out. But with that, it will now say, hey, I've got some tools for you. Now, it can give me the current time. So obviously this was a very complicated way when I could have just called the method, but we can start to do some more interesting things, because if I go back to my smart greeter and I can put in a system message and I can say answer only in Greek. And then over here, what we should then get is, well, it could be saying anything really, but we'll just, yeah, hooray. So far, this is still interaction back and forth with text. So let's do one more thing, which is, let's make something where we're going to say, I'm going to return, instead of returning a string, I'm going to return a pet. And I'm going to just say suggest pet. And so because instead of just returning a string, I'm going to be returning structured data. So I'm going to make a record pet. And then let's fill that in. And then let's make an enumeration here. And let's fill that in. And so now, if on my resource I add a new method, and let's call it pet, and let's call that pet, and then let's call that pet, then what I...
Type pet.
Oh, thank you. And
Create the method.
I thought I had created the method, but let's have a look. Oh, it's suggest pet, that's why. So now I can start to work in the domain model of my application and actually pass around structured data. And so if I go back here and if I do this, then, and you can see there's a bit of latency as well, because so far we're still getting times in Greek, and I'm fairly sure that's not the, okay, cool. So we've got, this is, I think that's JSON that the browser has converted, but we can check, because we can do one last thing, which is, Quarkus has an extension called Quinoa, and what Quinoa does is it just makes a lot of the decisions about how you integrate a front end and a back end. And so I'm going to copy in a web UI I made earlier. And let's copy that in. And then if I go here and if I hit my application, then it should eventually, this is where we get nervous and start looking at the logging.
Must be out on the feeds.
I think it might have done it now. No. What's it doing? I think it did do it, didn't it? So we got the JSON back, but we just slightly messed up that integration to the front end, despite, oh, it's because I think I did the wrong endpoint. So here, my endpoint is supposed to be called something else, and it's supposed to be called it is called pet, isn't it? Oh, thank you, media type. Thank you. And that was why it looked so unlike JSON when I, thank you. Thank you. Yep. Hooray. Okay. So now, hooray. So you can see now we're sort of converting this into an actual application. And if I hit it again, then we will have another excruciating delay. And then we'll get a similar but different pet. And so this is sort of a good opportunity to talk about a bunch of things, one of which is timeouts. You probably do want to set a timeout on your call, so there's an annotation for that. Another one is fallbacks, so that when OpenAI is down or whatever, you can just use the normal microprofile at fallback annotation. Another thing that you probably want to consider is I haven't been able to tune the prompt so it doesn't keep suggesting snakes, which I think is because it's irritated that I insulted Python, so it just keeps giving me snakes back. So you can put a guardrail in to do things like, please stop suggesting snakes, or please don't give a pet that will eat my other pets in my household, or various things. Or if you're using Ollama, it tends to really struggle to produce JSON. No matter how much you say, please just produce JSON. And so LangChain4j under the covers will be doing that. Ollama will still go, oh yes, I'm totally on it. Here's my thing that's only JSON. So then you can have some guardrails to do the JSON detection. But I think with that, I will stop doing the coding because I know we're pretty much at time. I just want to show you the, I had a guardrail, and at one point I got the parameter name. So I passed in the pet's name rather than the pet's type, and I got a noodle is not a snake. And it's this kind of stuff that we are computer programmers for, is so that we can have, have this. I mentioned latency is a problem. Fault tolerance and fallbacks are the solution. If you're actually using this in production, you want security. You want to be integrated into something that has that kind of production readiness. It can get expensive as well, so that's where you need that observability. And, you know, as others have mentioned, smaller models are a pretty good way of keeping a cap on the costs too. Or maybe you didn't even need an LLM for all of this. Maybe actually you want a hybrid solution that involves a rule engine somewhere in there too. But with all of that, you know, it is not magic. It is a stochastic parrot, but it is still pretty enchanting and amazing what it can do. So with that, thank you very much. I've got the slides are there, and the sample code is also all there as well. So thank you.
Amazing talk. Thank you very much.
Thank you.
Any questions in the room? Yes, and if you repeat it, that
Yeah.
would be amazing.
Very same question, but in what ways do you think that LangChain4j is like better than Spring AI?
So the question is, in what ways is LangChain4j better than Spring AI? I'm probably not the right person to answer that for two reasons. One is, of course, I'm not neutral. I work for Quarkus. But the other one is, to be honest, I have never used Spring AI. I do know, again, in my, you know, with my non-neutral perspective, that we tend to find neutral people come to us and say, you know what, your API is so much nicer than the Spring AI ecosystem API. But I think a lot of it then will sort of end up being a choice based on the other characteristics of the framework. So, because you're going to be doing AI, but you're going to be doing a whole bunch of other things as well. So with Quarkus, we are really proud of how cost effective we are to run, because we use, like, our throughput is way higher than Spring. So it means you can run on like a quarter of the resources. And our developer experience is also really great because of the live reloading and the dev services and all of that. So I would say consider that, and also consider the actual Spring AI and LangChain4j aspects.
Can I do a quickie answer?
Yes.
The cheeky answer is, can you go find out and come back and tell us?
Yeah.
Because you can do a great talk on it. Yeah.
Any questions? I don't think we have any questions online. So with that, give an amazing round of applause to our amazing.
Thank you.
Is there anything you wanted to say to finish off? Oh, there we go.
Just wanted to say goodbye to the vJUG people. So we will see you soon. We have another virtual Java user group event. I think it's next month, but check the meetup for that. Anyone here that wants to join us, we're always online and virtually. And if anyone watching wants us to live stream their events, I need to stand close to you for my microphone.
Oh, sorry.
Their events, just reach out to us on vJUG and we'll live stream your events. All you need is a laptop and we can do it. And for everyone in the room, we'll put some more beers in the buckets. There's like 5 more slices of pizza left, and anything else from LJC?
If you could fill out that survey that Steve put on at the beginning, that would be amazing.
Yes, you don't get to leave without filling it in. We've got your names.
Yeah. And if we can have another round of applause for our other amazing speakers as well.
And for Tessel.
And for Tessel for hosting.